بسم الله الرحمن الرحيم. In this part, we are going to speak about the surface integral. Last time we spoke about the surface area, or we found the surface area using the double integration. Now we are going to speak about the surface integral. The surface integral is just an integration of, or double integration of some given function over some surface. This is similar to the line integral. In the line integral, we said that the line integral just defines the integration of a function where that function is evaluated along some curve C. Same idea for the surface integral. The integral or the integrated function will be evaluated over some given surface. But we are going to use double integration to find the surface integral. So let G be a function of three variables defined over a region of 3 space containing the surface A, S. Then the surface integral of G over the surface S is given by double integral of S of the function G x y z ds. The double integral over the surface S of the function G of x y z ds. We know that the differential of the surface area is given by integration by the square root of 1 plus f of x squared plus f of or f sub y squared dA. So this integration can be written is equal to integration of r or of the function g of x y z is a function of x y. If we define the variable z as a function of f as a function of x y, so this will be integration of g of x y, and the function f of x y just replace it by the given function multiplied by square root of 1 plus f sub x square plus f sub y square dA. This is the first formula. Let me call it 1. Now, if y is a function of, let me call it h or g, x and z. But the projection now is on the xz plane, not in the xy plane. The surface will be projected on the xz plane, so the function or the variable y will be defined as a function of x and z. In this case, the integration, this will be the second formula, integration of g x y z ds over the surface S is given by r of dx and replacing y by g x and z multiplied by square root of 1 plus g of x square plus g sub z square dA, where g is a function of x and z. Third one, now if x equal to a function of y and z, then the surface integral x y z ds will be double integral over given region R. X will be a function of y and z, y and z multiplied by the square root of 1 plus h sub y square plus h sub z square, the partial derivative with respect to z and y. dA. So it depends on the variables x, y, and z. Without that, we are writing z as a function of x, y, or writing y as a function of x and z, or writing the variable x as a function of y and z. Let's have some example about the surface integral now. Example. Let's evaluate the surface integral. Integral subject j x y z ds. Say this is the first one. The given g of x, y, z equal to x. And S, the portion of the cylinder, is equal to 2 minus x squared in the first octant. Bounded by x equal to 0, y equal to 0, y equal to 4, and z equal to 0. Need to evaluate the surface integral. Notice that my function is z equal to 2 minus x squared. So z is defined as a variable of x and y. But since there's no y, means it is like you could say y as 0 in this case. Is equal to f of x and y given by 2 minus x squared. So z sub x equal to minus 2x, z sub y equal to 0. So the surface integral now will be given as r of g x, y, and z. Z given by 2 minus x squared of the function that will be 1 plus z sub x square plus z sub y square dA given by my function is g x y z, which is equal to x. So all that I have, this function equal to x. given there in the question. So it is x multiplied by square root of 1 plus this square, this sub x square, which is this one. If we square it, we get 4x square. Plus z sub y equal to 0 dA. Let me, this is the region that we have. What is R? Because we are going to integrate this over R. So what is R in the first octant? I have y equal to 0. This is y equal to 0, which is x-axis. And y equal to 4. Now for x, I have x equal to 0, which is y-axis. This is x equal to 0. Now I need the other limit for x to make it a closed area. We are given that z equal to 0. So if we replace z by 0, z equal to 0, which is equal to 2 minus x squared. It means x will be, or x squared equal to 2, or x equal to plus or minus square root of 2. But since we are in the first octant, this will be reflected to be the first quadrant in the xy plane. So x will be square root of 2. It is the positive one. So the limit will be, okay, this will be R. So the limit, if we are using the type 1 or type 2 dy or dx, if I say type 1, that will be dy dx. The limit for dy 0 to 4 and x from 0 to square root of x. So integrate with respect to y, I will have 0 to square root of 2. Sorry, this is 2, not x. It will be x square root of 1 plus 4x squared multiplied by y between 0 to 4 dx, which is equal to, will be 4, take it outside, 0 to square root of 2, x square root of 1 plus 4x squared dx. Now we can do this by integration by substitution. Let u equal to 1 plus 4x squared. This will give me u equal to 8x dx or dx equal to 1 over 8x du. I will keep the limit till the end. So this is 4 x u to the power 1 half dx is 1 over 8x du. X will cancel x. I will have 1 8. Outside will be 1 over 2. Integration of u is equal to, or u to the power 1 half will be 2 over 3 u to the power 3 over 2. Write it back as a function of x. So the integration will be 1 over 3. U was given to be, or substituted by 1 plus 4x squared 2 power from 0 to square root of 2. So the integration is equal to 1 over 3 multiplied by 1 plus 4x squared to power 3 over 2. Small remark that for the limit of the integration, we can find the limit for the variable u, or just find the integration or independent integral for the u, then write the original function as it is, and write back the limit of the variable x, which are 0 and square root of 2. From this one, we can find the limit for the variable u. One way, or just keep it as it is and then write it back and use the original limit, that's it, 0 to square root of 2. Now to evaluate what we have 1 over 3. Replace x by 2, it will be 1 plus 4 multiplied by 2 to power 3 over 2 minus 1. That will be 9, or square root of 9 to power 3 minus 1. That will be 27, 26, it was 26 over 3. And that will be the value of the surface integral.